Hi everyone. Today we are going to study the design issues of transport layer, or we can also call them as the services provided by the transport layer. So the transport layer provides reliable, cost-effective data transport from source machine to the destination machine independently of the physical network or networks that are in use. So let's look at the design issues or the services provided by the transport layer. The first service is addressing. When a user wishes to set up a connection to a remote application process, or in a simple language, when a user wishes to set up a connection with another host or another user which is remotely located, it must specify which one to connect to. That means it must specify the address of that particular machine or host to which it wants to connect to. Just like if you want to deliver a mail to someone's email ID, you must specify the email address. Only then will you be able to tell which host you want to connect to. So similarly, in order to transfer the data, in order to send the data to a particular host or machine, the user sitting on that machine which wishes to transmit the data must specify the address of that machine to which it wants to transmit. Unless you specify the address, it is not possible to deliver the message, right? So transport layer adds a specific type of address to its header. Now to the header field of the data, the transport layer adds a address which is referred to as the service point address or the port address. This address which the transport layer adds to the header of the data field, header field of the frame, that particular address is also known as your service point address or port address. With the help of this address, each packet reaches the correct computer or the correct destination, and also transport layer gets the complete message to the process on that computer. That is, with the help of this address which we call the service point address or the port address, the packet successfully reaches its destination, and in the destination to that specific process of that specific computer, because within a host or computer you have so many processes running. So this port address helps you to specify exactly to which process of that host you want to communicate. Say for example, in your computer you have Gmail opened, you have Yahoo Mail opened, you have Messenger opened. So if that message is intended for Gmail in your computer, so first of all the host address that you get to know with the help of the MAC address, and then with the help of the port address you get to know that specific process on that particular host to which you want to connect it. Because you are a host, your host to reach to you, your MAC address is enough, but to reach to a specific process on that particular host you need to know the port address. So a message intended for Gmail will reach Gmail only and not Messenger or Yahoo Mail. So this has been made possible with the help of port address or this service point address which is provided by the transport layer. Therefore, the first and foremost service that is provided by the transport layer is your addressing. Then is segmentation and reassembly. Now basically, large data altogether is not transmitted at once. If a data is very large, so it is first of all fragmented into smaller pieces which you call frames or datagrams, whatever you may call them at different layers. But basically a large message is broken into smaller units. So this process is known as segmentation, which basically involves dividing a message into transmittable segments which can be easily transmitted, and each segment then contains a sequence number. Now the basic reason for providing the sequence number to each segment is that at the receiver's end, when they will be reassembled, the receiver must know in which order they must be reassembled. So that is why each segment is provided with a sequence number, and then they are transmitted according to the sequence number only. So this number enables the layer to reassemble the message. Basically, with the help of the sequence number, the receiver knows how to reassemble these segments back into the original message. So sequence number 1 means that segment will come first. Sequence number 2, that segment will come first, and so on. So there are two cases in this. First of all, you transmit these segments in their sequence number only, in the order of their sequence number only. So segment 1 will be delivered first, segment 2 will be sent after that, segment 3 after that, and so on, like this. So in this case, there is a possibility the segments reach the recipient in the same order in which they have been transmitted. Now there is a probability that the segments may reach out of order also in some cases, right? So if, for example, you transmitted segment 1 first and then it reached the destination, then you transmitted segment 2 and because of some reason it got delayed, and after that you transmitted segment 3 and it reached the destination before segment 2. So this is out of order delivery. But at the receiver's end, when the receiver will reassemble those segments, it will not reassemble them in the order of delivery, but it will reassemble them in the order of their sequence number. So even though segment 2 reached after segment 3, but while reassembling, segment 2 will come before segment 3. This is all big thanks to the sequence numbers that was provided with the segments. So because of this, upon arriving at its destination, system message is reassembled correctly. Now the third service that is provided by the transport layer is connection control. Now basically, you all know by now, you have reached a stage where you know that there are two types of connections that can be provided. One is your connectionless and services, and another are your connection oriented services. So these services provided by the transport layer, hence they are also known as connectionless transport layer and connection oriented transport layer. Now first of all, let's look at the connection oriented transport layer, or the connectionless transport layer, or the connectionless service provided by the transport layer. So this service provided by the transport layer treats each packet individually. That means each packet is treated with its individual identity, or each packet is treated individually and is delivered to the destination, and it is delivered to the destination machine. So each packet is treated independently of the original message and is delivered to the destination machine. So in this type of transmission, the receiver does not send an acknowledgement. In the connectionless type of service that is provided by the transport layer, the receiver will not send an acknowledgement to the sender about the receipt of the packet. So this is a faster communication technique. So since the acknowledgement of the receipt of a packet is not sent to the sender by the receiver, so hence we can say it is a lesser reliable service, because there is no acknowledgement of the packet being received. So you do not know whether the packet has been received successfully or not. So a slightly less reliable service, but the plus point is that it provides faster communication technique, because a lot of time and bandwidth is saved by not sending an acknowledgement message back to the sender. Now the other kind of service that is provided by the transport layer is the connection oriented service. In connection oriented service, a connection with the destination machine is created before transmitting the packets to the destination. So basically, a dedicated connection is established between the sender and the receiver, which will be used throughout the communication for all the messages that will be transmitted from the sender to the receiver. Unlike the connectionless, wherein you treat each packet individually and then you can transmit those packets belonging to the same message from the same receiver through any of the outgoing lines. But here, once a dedicated connection has been established in the connection oriented services, then that connection will be used throughout for all the packets of that message. Hence, packets are not treated individually, but they are treated as a part of the same message, because they are following the same path. The same path which has been followed by path 1, packet 1 will be followed by packet 2, 3 and so on. So just one dedicated path, and that will be used by all the packets of the message, right? So this is the concept of connection oriented service that is provided by the transport layer. So in order to create a connection, obviously when you have to transmit a packet through the same transmission line using the same connection, that means you need to create that dedicated connection first of all. So 3 steps are involved, which are also known as handshaking. So the first step is connection establishment. That means in order to establish a connection, in order to transmit the packets, you must first establish a connection. Once the connection has been established, you will transfer the data, and once all the data has been transferred and that connection is no longer required, you would terminate the connection. So these are the 3 steps in a connection oriented service. It is very similar to the dial-up telephone connection that we use at home. So before we can talk to someone, we must establish a connection with that person. That means you dial the number, a connection is being established. Now when the receiver at the other side picks up the phone, the connection has been established, and then you can start transferring the data. That means you can start talking to each other. Once you are done with talking, that means you have no more data to transfer. You will not use that line or connection anymore, and you hang up. That is, you terminate the connection. So this connection oriented service is quite similar to the dial-up connection that we use, which involves 3 basic steps: connection establishment, data transfer after that, and once you are done with data transfer, connection termination. So the connectionless service is less reliable than the connection oriented service, for the obvious reason that connection less service does not provide any acknowledgements, whereas the connection oriented services provide acknowledgements, so you know whether your data packet has been successfully received or not. And for a packet for which you do not receive the acknowledgement, you can retransmit it to ensure that at any cost the data reaches the destination. Okay, so the fourth service provided by the transport layer is multiplexing and demultiplexing. Now before this also you have studied what is the concept of multiplexing and demultiplexing. You can refer to my previous videos. I will put the link for that. What is multiplexing and what is demultiplexing, and by now at this stage, I assume that you very well know the concept of multiplexing and demultiplexing. So multiplexing is basically multiple packets from diverse applications transmitted across a network through the same line at the same time, right? So these kind of dedicated mechanisms which are used in multiplexing are found in the transport layer. So basically the transport layer accepts packets from different processes, multiplexes them, and then transmits them. So this saves a lot of time and even bandwidth. These packets are differentiated by their port numbers. So for which particular process on which particular host they are intended for, that is identified with the help of the port numbers. So just like the MAC address help you to identify a specific host, the port numbers help you to identify a specific process on that specific host. So how do you, when these packets are multiplexed together, so how do you identify them as different packets? It is with the help of their port numbers that you are able to identify, okay, this packet is for this specific process on this particular host, and then they are passed on to the network layer. Here from the transport layer, after being multiplexed, they are passed on to the network layer after adding proper headers, which basically include the addressing. After being transmitted at the receiver's end, that is demultiplexing is done. So in demultiplexing at the receiver's end, the data coming from various processes is filtered, and the data intended for a specific process is taken out from the demultiplexer and delivered to that specific process on the specific computer. Hence the filtration of this data which has been multiplexed is done, so that the specific data reaches to a specific process on a specific host, and then it is delivered to the appropriate processes running on obviously the receiver's machine. So on the receiver's destination machine. So in this type of transmission, the receiver does not send an acknowledgement. Here also the receiver is not sending any acknowledgement to the sender about the receipt of the packet. Okay, so next is your flow control. The next service that is provided by the transport layer is your flow control. So what is flow control? Basically, you have started this thing also earlier, that flow control is nothing but managing the flow of data that is coming from the sender to the receiver in order to stop the receiver from being swamped by the sender, because it is not necessary that both the sender and receiver have the same speeds. There is a possibility that the sender has a higher speed and the receiver has a slower speed. So if a sender has a higher speed, it'll transmit the data at a much higher rate, and if that rate is higher than what the receiver can receive and process, then the receiver will be swamped and a lot of data will be dropped or wasted in this case. So we do not want to swamp the receiver. Basically, we do not want the loss of data. So for this reason, flow control is used, which is provided by the transport layer, right? So transport layer is also responsible for flow control mechanism between the adjacent layers of the TCP/IP model. By imposing flow control techniques, now there can be several flow control techniques which we have studied already. So by imposing any of the flow control techniques, data loss can be prevented from the cause of sender and slow receiver, right? So for instance, one of the flow control method that can be used is the sliding window protocol that we've already studied. And we know that in the sliding window protocol, in which the receiver sends a window back to the sender to inform about the size of the data that can be received. So with the help of the window size, the receiver knows the the sender knows the size of the receiver's buffer's window, so it will send data accordingly and not more than the window size or the buffer size of the receiver. So there are many such flow control techniques whose link also I will provide in this specific video's description, so you can refer to various such flow control methods also, like the sliding window protocol, the go back ARQ, go back NARQ and ARQ, right? So I'll provide a link for those flow control methods also here. Now the last service or that is provided by the flow transport layer is your error control. Error control basically ensures that the entire message arrives at the receiver's end or the receiving transport layer without any error. And when I say without any error, that means no changes in the bits whatsoever, no damage, no loss, and also no duplication of data. So error correction is achieved through retransmission of packet. Whenever there is a loss of data or there is a negative acknowledgement or there is a no acknowledgement received for a particular data, you retransmit them from the sender side. And if at the receiver side a duplicate data is received, with the help of sequence numbers you can discard the duplicate message. So all these things helps in error control. And to see if the data has arrived or not, for checking the integrity of data, basically acknowledgements are used, which can be the positive acknowledgement also known as ACK and the negative acknowledgement known as NACK services, which inform the sender whether the data has been received or not, right? So with the help of ACK, the sender knows that the acknowledgement that the data has been received, hence it received a positive acknowledgement. When NACK message is sent by the receiver, the sender knows that the data has not been received, it is a negative acknowledgement and it needs to retransmit data. So this is how error can be controlled at the transport layer.